Okay, so the first thing that we are going to do here is we'll start Civil 3D. Now you know you have already created the surface, right? So now what we are going to do is now we are going to create the alignment. Now you know any road, any road or highway, they are 3D objects, but they can be projected into two planes. One is horizontal, the other is vertical, right? So what we are going to do today is we are going to create the horizontal alignment. Okay, later we are going to do the vertical alignment, and then finally we are going to combine the two. Finally it is just one road. Okay, it is not that there is only one road here, horizontal, one road there, vertical. No, it's just a unique entity. But for the easiness of the design, we are going to do horizontal alignment first and then vertical alignment next, right? So the first thing we'll open our uh, day one surface. Okay, now this is day one surface. Okay, this is day one surface, and if you go to surface, here there is this surface XML as well. So that means this surface being exported into XML format. So you remember last day, maybe you remember I showed you, if you double click this one, right? So this is Civil 3D, everything converted into text. So these are the points, and after the points there may be say you have the break lines and things, and these are points. Here what is this? So they are usually they show points and boundaries, and then the break lines and everything they show here. Okay, these are points, right? So anyway, don't worry. What we are going to do is we are going to import this in back to a Civil 3D file, and we are going to interpret that. Okay, so I'll show you how to do it. So this surface is there. Now I'm not going to do anything with that. It is already done. I'm going to close it. Okay. Now after that, what I do is I will again load our template. Do you remember that we uh, loaded a template? This one, file new. So you go to here. This is the template. So I think I shared this with you, right? Now there comes an error message. This drawing was last saved with an earlier version of the software. This is a false, not a false error message. This is of course correct, right? But we are going to close it, right? Then continue with current command. Okay. Then I'm going to save this template. Now it has become a file, source file. So I'm going to save it as file save as. So I will create another folder. Sorry, day 2. Day 2 I will be saving it as alignment. Okay, now this is just a Civil 3D file loaded with UM template. Okay, now what I'm going to do is I'm going to copy the service drawing and going to paste here. So for that I will open sorry, file open, desktop, day 1 initial data, example survey drawing. Okay, so I'll open this. Now you know this drawing file was saved by an application that was not developed by license or licensed by Autodesk. That means this was done by some other program by the survey. It doesn't matter. Okay, but if you if you press cancel opening file, the file will not be open. So what we do is we'll go to continue opening drawing file. Okay, now what you can do is you can copy this one like this, edit copy, and then shift to alignment, and you can paste to original coordinates. Paste to original coordinates. Now, if you can't find it, what you can do is, now I can find it. If you can't find it, what you can do is, say it is somewhere there, Z enter, E enter, that is zoom extend. Right, now this is our what? This is our surface drawing saved into the copied into the UM template, right? So we can save the drawing. Right, now our example survey drawing, we can close it. Right, no, because we are not going to save anything that we go to do with the surface drawing. That is an original one, right? Okay, now we have to import the surface that we created. Now do you remember that we created surface and saved it as surface XML? Now we are going to import it back. File, import land XML. So you go to your relevant folder, day 1, surface. Here there is the surface XML. We are going to open it. Okay, so how we are going to do it? File, import land XML. Okay, surface, open, and then press OK. Then you can see that surface is being imported. Here this is the surface. This is the surface. Can you see that green color boundary? That's a surface, but it is not very beautiful like the earlier one, because this is a different format, but we can bring back that format. You select the surface, you go to surface properties, select the surface, go to surface properties, and here under surface properties EG is the name of the surface, and surface style you can go to contour points and triangles and borders, contour points and triangles and borders. Then apply. Okay, right, now this is the earlier surface, but you know with this surface it is quite difficult for us to do the design. So what we do is we are going to make it invisible. Okay, we are not going to delete it, we are going to make it invisible. So you select the surface, right click, go to surface properties, and then surface style, you put no display, apply. Okay, right, so what are the white line, what are these white lines? If you select this line, what is this one? You go to home, that is EG break line. So these are the break lines created by the EG surface last time. So we are going to switch off this layer. All right. Now there's another thing. These points, these points we should not keep it here. So we can switch off these points as well. Select that switch, select that point. What is that one? 0. But you can't switch off this 0 layer. Just think, if you are going to switch off the 0 layer, and now it worked. Sometimes it is a bit difficult because the survey has done everything in the 0 layer. Then everything is gone, right? And I am going to close these two lines as well. These red lines, these are 30 feet lines. We don't want. There is no significance in 30 feet line. Why the survey has taken 30 feet line is we ask him to take the survey for 15 feet into one side. 15 feet into one side from the center line. So this man, he went and he marked the 30 feet line as well. So that is not necessary for us. So we can switch off it. Okay, so these are the lines we want. Existing center line, right? Then tie TE, LHS tie, right side tie. Okay. Now we are going to do the alignment, right? Now we are going to do the alignment. Now before that, you have to refer this table. This book I have given you. Okay, this table is extracted from the RDA manual, Geometric Design Standards. Here, Geometric Design Standards of Roads Road Development Authority. Okay, now please understand, this table may be quite different from what you are learning at the classroom. Because as far as I know, University of Moratuwa is teaching you AASHTO standards. Okay, so these are some two different standards. This is AASHTO. AASHTO is the American standard. Okay, American standard. And AASHTO is the Australian standards. Now in RDA, for all the national roads, AASHTO is used. So this book, Geometric Design Standards of Roads Road Development Authority, that's an RDA publication. This is based on the AASHTO standards. Okay, this is based on the AASHTO standards. And AASHTO is somewhat advanced. What I mean by advanced, their superelevation development method is quite different from that of the Ostros, and they require large radii for the same speeds. Now here the design speeds, and these are the radii, these are superelevation. Now how do you read this table? This is how we are going to read this table. Now if your design speed is 50, if the minimum radius you can provide is 95, so you have to provide 4% super elevation. That means if you want to provide 50 kmph, if you want to provide 50 kmph design speed, but your permissible radius at the site is 95, you have to provide 4% super elevation. If the permissible radius at site is 100, then you have to provide 3% super elevation. If the permissible radius at the site is 105 or more, you can provide only 2.5 plus. That's 2.5 means you have to super elevate, right? This is not minus 2.5. This is not the normal crossfall. And there is another thing called adverse crossfall. If your design speed is 50, if this is an open area, that means it is not built up. This is a village area. Village area in the sense the surround is not built up. Then if your radius is greater than 565, you don't have to provide super elevation at all. You can go with the normal crossfall. So before going for the horizontal alignment design, you have to know these two tables. Okay, that means you don't have to by heart them. You should know this one. Okay guys, Right, then we shall start designing this alignment. Before designing this alignment, you have to decide what is your design speed. So you cannot just decide what is this design speed by ad hoc means. So you have to do the feasibility studies, you have to do the proper planning and all these things, and you have to consider what is the maximum speed that under which the drivers are driving in this area. After all these studies, that is planning, right? So I am not here to teach you planning, I am here to teach you design, right? Computer design. But I think so when it comes to the road planning, there are desk study, then the reconnaissance survey, and then preliminary survey, detailed survey. All these things. Okay, this is for they are for a new road. But when it comes to rehabilitation road project, you don't do all these things. But one thing you have to do is you have to consider what is the design speed that you have to follow. Now, usually in Sri Lanka, there are two design speeds. Okay, one is 50 kmph, other one is 70 kmph. So, in urban areas, you are usually going for 50 kmph. Okay, urban areas you are going for 50 kmph, right? And rural areas you are going for 70 kmph. Now, by the look of this site, you can see this is an urban area. Can you see? So many houses or buildings are nearby. So this is an urban area. Okay, therefore we will select 50 kmph. So if it is 50 kmph, you have to give you have to provide radii in this range. So usually if it is flat terrain, we do not go beyond 4%. Okay, so at least you have to try 95. But if you can't try 95, then what you are going to do? You cannot provide 95. So we can go one step down and select this range 60 to 55. Okay, right. With that, okay, I'll tell you. So you have to go to this page, horizontal alignment. So we are going to start from here, starting an alignment in Civil 3D. Okay, so you can refer these steps, right? So I think you can get a printout of this and then keep this one with you. Okay, then we shall start designing this alignment. Okay, using Civil 3D. So you go to alignments, create alignment by layout. Okay, alignments, create alignment by layout. Then there comes create alignment toolbox. Okay, then there comes create alignment toolbox. So you have to give a name. Usually we give a name DCL, that is design center line. Okay. Then type is center line. Site, there is no site, but you can create one. What is this site? Site is, just think it is about something like a folder where you go and place your alignments. The same folder, say something like, so if I put this one as site 1, so I'm going to put the DCL and then H. edge alignments, road edge alignment of this road. Say the center line of this road edges of this road, and existing road edges of this road, everything I put into site 1. So that is just like a folder. Okay, so you can create one here, site 1. Okay, alignment style, you can keep it as alignment label set, you can keep it as Now once you have finished these things, now check the name should be DCL. Here the type should be centerline. And this one is site 1. Site is site 1. Alignment style is Alignment layer you can't change. Alignment label set is So you can press OK. Here, something like this. Press OK. Then you get alignment layout tools. Using these tools, you can create the alignment. Okay, using these tools, you can create the alignment. Now you know, since this is an existing road, we should try as much as possible to follow the existing center line. So this yellow line is the existing center line. Okay, so this yellow line is the existing center line. So we are trying to fit our alignment. That is why we call it curve fitting. Okay, earlier before the computers came, at that time we called it curve fitting, because that we are going to fit the curve into an alignment. Okay, so here, so you have to consider the shape. Now what is the shape? What I feel is, this is just like, say, first you are getting a small straight. After that you are getting a curve like this. Is it okay? Do you see it as same? First there is a straight, and then you are getting a curve. After that another straight. This is how I feel. So we shall try this. Okay. Now one thing you have to understand is, here when you are trying to design an alignment using Civil 3D, you have to start either with a fixed line or a fixed curve. Okay, after that you can go for floating lines and floating curves. Fixed means that line or curve is fixed, you can't change it. Okay, we call it pegging the alignment. So you go and peg it somewhere at the field. Okay, so now don't worry about much advanced details. We'll just think that you have to start an alignment using either a fixed line or a fixed curve. So I'll get the fixed line 2 points. Okay, fixed line 2 points. Right, once I click it, I am getting specify start point. So I am going to specify the start point. And here there comes a line, right? So I can keep it anywhere I want. You can switch off offset here. What if I put it like this? Okay, doesn't it follow the existing center line? Okay, up to here it is following. So I'll put it like this and right click. Now you can see our alignment is drawn up to 34, right? After that there comes a curve. So how do I know this radius of this curve? One thing is, you can go by trial and error. You can try so many curves. But one trick I am using is, I am using some AutoCAD tool bit. Here, using this tool bit, I go to uh, start and direction. Using this arc, start and direction. I just draw. This is not Civil 3D. This is just uh, AutoCAD, right? So I'll select one here, and then I will try to match this curve with the existing one, right? Now once I select this one, go to list li. So the radius is 82. What did I do? Since I didn't know this, the radius of this curve, one thing is I can go for trial and error, starting from 100 or something. But instead, to get the radius of this curve at one shot, what I did was I used an AutoCAD tool bit here. Here using this start and direction, using this arc. Okay, so what I did was I put one point here, another point here, and then I tried to match it as much as possible with the existing curve. And then I got the li list. So it is 85. Okay, so now I have a rough idea. This curve should be 85. So quickly I'll go back to my table. So can I go to at least 50? No, I can't. If I am going to give 85, then I have to give 7% super elevation. This is not going to work. Now can you see here, of course this is a bridge. Now if you are going to give 7% super elevation here, you cannot all in suddenly you can't give super elevation. You have to gradually increase it. So your super elevation development will come into the bridge, and that is not permissible. Okay, because you cannot have super elevation changes in the bridge. So that means you are going to put your structural colleagues into trouble. Okay, so what we do is we go one step down. Okay, we try to go one step down. Here 40. Then of course if you can give 85, 2.5 super elevation is okay. Understood? Right. Now what I do is I'll give 85 here. So for that I'll get floating curve from entity n 2 point. Sorry. Floating curve from entity radius 2 point. Okay. So that is from an entity. So I am going to consider that my first element, that is the fixed line, and then I am going to give the radius and true point. True point means I am going to keep it somewhere. So this may be okay. Floating curve from entity radius 2 point. Okay. So I'll select this one and then select entity to attach to. So I'll select this one. Now don't select it somewhere here, right? At this end. It's not going to work. You have to select this end. Specify radius or degree of curvature. So this is radius, we shall say 85. Enter. Then it asks, is curve solution angle greater than or lesser than 180? So I always say this is a stupid question. So what does this mean by greater than 880 or lesser than 880? When two lines intersect, you know there are two angles. Okay. So what are these two? One angle is less than 180, other angle is greater than 180. Both sides. So I don't remember the name of that angle. Now next time I should ask my son to tell me. That is, I don't remember. There is a name for that, right? So anyway, then when it comes to a road, it is always lesser than 180. Okay. wait, I'll tell you what is that. So what I'll do is I'll try to keep it somewhere here. See, right click. Okay, so up to this point the alignment is created. So what I told you last time is, when there are two lines being intersected, here one angle is lesser than 180 always, the other angle is greater than 180 always. So that's, that is, you can call it a theorem or something. Okay, that is standard, or that's a convention. Okay, so what they are asking is, when you are going to have a curve here, whether you should consider this part or the other part. So I don't know why they are asking that question. In a road you can't consider the other part, other road. Okay, so now we have finished up to here. Then what is this one? This is a straight. So you have to draw a straight. How? So you can, now earlier we used the fixed curve. Now what you can do is, you can select floating line from curve through point. Floating line from curve through point. Okay. So it says select entity to attach to. So do you see that red one? What does that mean? That means you can't keep it there. There's no such solution, because they should be tangential, right? So what I'll do is, I'll keep it like this. Okay, right click. Now can you see the alignment is drawn up here. Then you have another curve this side. Now that is only giving curves. Okay, we'll see. Say what should be the curve radius. I'll take it as 250. We'll try, right? Floating curve from entry, radius 2 point. Select and to attach to. Okay, this one. Radius say 250. Less than 180. No, it is greater than that. But what one thing you can do is, you can keep it like this, right click, and you can select here pick sub entity, and you can select this one. So you can give the radius. Say I'll try to give 300. It is not okay. So I'll try to give 400. No, still some more. Say 500. Seems okay, right? And it seems this has a small straight. For that you can go to floating line. Here. And there's another one. Again we'll try with 250. 250. Lesser than 180. Now it is somewhat wider, so we can reduce it. Here we'll try with 200. No, 150. Say 160. Seems okay. So all are greater than here 105. Then no need to worry. Then what is this one? That is a straight again. So what I'll do is, I'll go to floating line. I'll select this curve and go up to here. Right click. Okay, then there is another curve. This curve, how much do you think? 100 We'll try 100. 100 lesser than 180. No, it is. Now if you think this is wrong, you can select this one and you can take it here. Here. Okay, now your radius is higher, so you can reduce it. Say lesser than 100, right? So you have to check your book. So you have to provide minimum 55, right? Beyond that you can't go. So we'll try with some, say, 80. No. Thanks. Thankfully we can go up to 90, but can you see that it is not very properly matching? What you can do is, maybe it is two curves. We'll try with two curves like this. Then it is lesser than 90, right? So what you can do is, you can go to say 80. Now it seems okay. So this is another curve, right? So this may be something like 100. We'll see. So we'll select this one, select entity to attach to this one. We'll give the curve as 100, lesser than 180. So it asks, is curve compound or reverse to curve below, curve before? So it's compound, right? Because same direction. Compound. So we'll try to put it here. Now it should be greater than 100. It is obvious, right? So you can try with some higher radii. Say 110. Somewhat more, 120. Even we can try with 130. Okay, that's enough. Then there comes, now suddenly if this goes, so what you can do is, say it is not coming, see. So what you can do is, you can take this table sub-entity editor and then you can select here. Another thing is, if your alignment is gone like this, alignment to tool set, then don't worry, you select this alignment, go to edit alignment geometry. So it's there. Okay. Then after that, you can draw this line, floating line. Select entity to attach to this one. Here. Then again there is a curve. So possibly it should be 60 or something. Okay. We'll try 60. Floating curve. Say try with 60. It's matching. After that there is a small straight. Okay, then there is another curve. What is this one? Say 60. We don't know. We'll try 60. Maybe somewhat higher. We'll try with 70. No, 65. But don't give some odd values like 62, 63. No. At least round it off to the nearest 5, right? And then this is straight. 14 line. Okay. After that, this one. How much do you think? 100? We'll try. 100. It is not 100. Can you see? Maybe 90 or 85 or 80. 85 is the perfect one. Then again another straight. Right. Then again another curve. How much do you think? 100? We'll see. 100. No, it is lesser than 100. Say here you can correct it by dragging. Then we'll try something like 90 or 80. Okay. And then this is another curve. How much will it be? 250? We'll try. Select this one. 250 lesser than 180. Say reverse. Is curve compound or reverse to before? Reverse. Press R. Enter. 250 seems okay. Or you can go something more. Say 300. So it seems perfect, right? Then there is again another straight. 14 line. Okay. And here you are going to get some problem. One thing you can do is, now here definitely this is something like 30. Now you cannot allow 30. What you can do is you can improve it. Okay. So we will consider minimum 60. So we'll try to have some 60 curves here. We'll see. Now here it should be say 100. No. We can have some higher curve here. Say 250. 250 is much more, right? So we'll go to 200, 450. Seems okay. Then we'll provide here 60 minimum, right? Then select this one, 60, lesser than 180, reverse. So 60 is coming like this. So this side will be acquired. Okay. And the other one also, we'll keep 60 and finish off the alignment. Select this one, 60, less than 180, reverse. It is greater than 60. So what we can do is we can try some other curves, say 80. No, what we can do is we can have it here like this, and finally we can end using a floating curve like this. Okay, now that is the end of our alignment. Okay, now I will share this alignment with you. Okay, so you can do the other parts with me in this alignment. Okay, file, save as. First I'll save it. File, save as, desktop, email. Yeah, alignment, right? Oh, we have to close this. Okay, so you can download it and then use it, right? So again, we'll open uh, this file that we created, alignment, right? So in my case, what I'll do is we'll go to Civil 3D and then open it. Okay, so you can go to File, Open, and go to your folder, Geom Day 2 Alignment. Now this is your alignment, right? Now if you want to know the radii and other details here, well, before that I'll tell you what are these things. Now this is the chain, right? Now this blue color chain edge is the minor chain edge, and this green color chain edge is the major chain edge, right? And these are geometry points. TC means tangent to curve. CT means curve to tangent. So that is the chain edge. It starts from curve to tangent. And if you go here, TC, that is tangent to curve. Okay. So but what do you know? Do you know the radius of this curve? It is not being shown. But we can do one thing. So you go to alignments, you go to add tables and go to renumber text. Alignments, add labels, renumber text. and there it is coming. Select label to renumber tag, go settings. What happened? Alignments, add tables, renumber tags, S settings, enter. So you have to make all these things one. Otherwise, the curve numbering will start in some other odd number. Okay. So apply. Okay. Right. Then you go to alignments, add alignment labels, multiple segment. Alignments, add alignment labels, multiple segment. Now it says select alignment. So you can select the alignment, press escape. Now you can see here L1, that is the line number 1. Length is 13.1112, sorry 112. And this is C1, radius is 85 meter, length is 90.503 meters. Okay, and here L2, line number 2, length is 135.231 meter. Here there is a curve C2. Here radius is 500 meters and length is 91.833. Now the only the benefit here is, say if you go to edit alignment geometry and if you try to change this one, say instead of 500 we'll try to give 400. Okay, see, so we'll give 450. It is being changed. Now your draftsperson does not need to correct it every time you make a change. It's been automatically changed. Okay, and after that, now this is only the center line alignment. What about if you want to have line alignments, so lane alignments as well? That means if you want to have 3.5 here, 3.5 other side, so you can have such alignments very easily. Here you select this alignment and then there is offset alignment. Okay, offset alignment. You select the offset alignment, offset name template. There is a name template. So you don't want to change it. Now number of offsets on left, that is 1, right 1. Incremental offset on left we will give 3.5, that is 1 lane width. Here 3.5. Alignment style we will give UIM. Label set we will give no labels because we don't want labels in other alignments. Only we want the label set in the center line alignments. Now please complete these things. Okay, so now once you press OK, here there are two other alignments here, one here, one there. Now if you want, you can select this alignment and you go to alignment properties. Here the name is DCL left 3.5. If you want, you can give DLHS, it doesn't matter, that is design LHS. And if you select this one, alignment properties, DCL right 3.5. If you want, you can give TRHS. Doesn't matter whatever you want. Okay, and you have to have hard shoulder as well. That is 1.5 offset from here. That means altogether 5. Here 3.5, another 1.5, that is 5. So what you can do is you can select this alignment and go to offset alignment, and here incremental offset on left 5, here also 5, alignment style is no labels, you press OK. So there is another set of alignments here. If you go to alignment properties, it shows DCL left 5. If you want, you can put HLHS, object style This one, alignment properties will give HRHS, that is hard shoulder RHS. Okay. So your road is being designed now. Now one thing, what is the benefit of this is, now rather than having creating separate alignments, the benefit of this is, now if you are going to change this alignment, an element of this alignment, these are going to be changed automatically. Now as an example, if I consider this one, see, I'll go to edit alignment geometry, select this alignment, go to edit alignment geometry, and I'll try to change something here. It is 100, so I'll try to make this to, sorry, it is 80, so I'll make it 100. Now look what happens to the offset alignment. See, 100, it is not accepted, so maybe problem with this one. So we'll consider some, yeah, we'll consider this one. Say we'll go to 100. Here everything is changed. Did you see that? Shall I show it again? Here it is 160. I'll change that into 100. Now see, once I right click, all these things are going to change. You saw it. Otherwise, if you have designed them as separate entities, this is not going to happen. So this is the benefit of creating them as offset alignments. Okay. Right. Save the drawing. Now we have to design our profile. Okay, now we have to design our profile. So for that, we'll save this as file, save as profile. Profile is the vertical alignment. Okay, now I told you in the beginning, a highway can be presented by two projections, one to the horizontal plane, other to the vertical plane. Now this is the horizontal plane. After that, we are going to project that into the horizontal plane. Okay. So for that, what you have to do is you can go to profiles, create profile from surface. So follow with me. Profiles, create profile from surface. Okay, create profile from surface. This is DCL. This select surface EG. So we are going to associate this existing ground. This is the surface that we have created. So we are going to associate this EG with our design center line. Okay. So we are going to add, right? And then draw in profile view. Okay, now there are 6 dialog boxes that we have to fill. Okay, so these are not very difficult. So the book describes how to fill them, but you can use the profile view name as EG profile style, that is 1000 that is the scale 1000 University of Moratuva. Next, station range 0 to this one, that is the automatic one, but just think that this is 50 kilometer road, so you cannot have 50 kilometer at once. So in such instances what you do is you go to choose a specified range and give from 0 to 5 or something like that. Okay, you go to next. Profile view height we are not going to change. Profile display options also we are not going to change. When it comes to data bands, you have to select 1000 Okay, then next, profile hatch options, of course we are not going to change. Then we'll go to create profile view. It says select profile view origin. We'll select some convenient location. Now you can see your profile is being created. Okay, this is the existing profile. This is the existing profile. Existing profile of the existing road. Okay, now you can see here. So these are what you are going to give: station, finished road level, existing ground level, vertical geometry, horizontal geometry, and superelevation. Now you can see superelevation is not provided, so you have to provide superelevation. Okay, and this is only giving the details in 20-meter intervals. If you want, you can put that into 10-meter intervals. Usually I put that into 10-meter intervals in rehabilitation projects. New road projects 20 is enough. So you can go to edit profile view style. So yeah, you can select this grid, right click, go to edit profile view style, and give this here horizontal axis major tick details, give it as 10. Then apply. Okay, right. So how you are going to give, the super elevation? So you have to calculate it. Okay, there is another method of giving the super elevation using an Excel sheet that I can give you, but uh, first we will go to manual method, otherwise you will not understand what we are doing here, right? Okay, so you go to prospector, alignments, no, sites, site 1, alignments, center line alignments, that is DCL, right click, edit superelevation. Okay, edit superelevation, and then it says calculate superelevation now or open the superelevation curve manager. So you can try with calculate superelevation now, but this calculates according to the AASHTO method. Okay, now you can give these details undivided ground. Okay, because there is no center median. Next, normal lane width is 3.5. Sorry, normal lane slope is minus 2.5. Number of lanes right 1. Okay, then next, normal shoulder width. Our shoulder width is 1.5. Normal shoulder slope is minus 2.5. So it asks shoulder slope treatment. There are two treatments given. Breakover removal. Low side is breakover removal. And high side match lane slopes. So I think it has to come other way around. Anyway, we'll keep it as this one. So I'll tell you later what is that one, right? So we'll go to next. Percentage on tangent to curve. Okay, so that means if there is a tangent and curve, how much percentage should come to tangent, right? So it is 2/3 according to according to Ostrots, but they are using Arsto, right? And if it is a spiral, it should be 100%. Then you tick this automatically resolve overlap, so you finish it. Now this is how your super elevation is coming. Okay. Now this may be pretty okay, but can you see that super elevations are different? Now as an example, everywhere they have considered 4%. Okay. Now this kind of problems are there because this is not what we are using here in Sri Lanka. Okay. So they are considering everywhere 4% super elevation. So that is not going to work. Right. So therefore we don't use this automatic method. Okay. So we'll remove that one. Okay. Edit super elevation. Go to tabular editor. And here by pressing this clear all super elevation data, everything will be gone. Okay, now we can do it manually. To do it manually, we have to find super elevation development length. So if you want, you have to calculate it. There are two methods. I think you have studied. What are these two methods? Let me show you. Super elevation development length. There are two methods: relative gradient method and rate of payment rotation method. Since I am not supposed to teach you theory, I am not going to teach these things. So what I'll do is I'll take super elevation development length as 36. Okay, for all the curves. But of course you have to calculate it yourself. Okay, you have to calculate it and get. But since I am not supposed to teach you this part, I am going to take it as 36. Otherwise we don't have time, right? So if we are going to go for the super elevation development length calculation, it takes time. There are two methods. You have to calculate the super elevation development according to these two methods and then get the maximum one. Okay, I think that you have already learned these things, right? So we'll take 36 and do our calculation. Okay, right. Then first thing that you have to do is you have to take this DCL, go to edit super elevation. Instead of calculate super elevation, now we go for open the super elevation curve manager, right? Then tabular editor, right? Tabular editor. Then you select this curve 1, and I'll do it again to space, site 1, alignments, endline alignments, DCL, right click, edit super elevation, go to open super elevation curve manager, and then tabular editor, and here curve 1, add station. So I'll add first station 0. Okay. So here if you expand this curve 1, there is transition in region manual station. So instead I'll go to assign critical station and go to begin normal ground. Begin normal ground. It is not coming sometimes, right? So that is a bug. So what you have to do is you have to tick this and come back using tabular editor here. Begin normal ground. Then what should be the super elevation there? So that's the problem. Now if it is 36, you know, according to Ostrots, 1/3 should be inside the curve and 2/3 should be outside the curve. So this station is 13. Now if it is 36, 1/3 is 12, 2/3 is how much? 24. So you can't remove 24 here. Okay. Therefore now don't worry here that we'll do it later. Therefore we'll consider this as fully super elevated. Okay, no super elevation change. So here this is turning this side. Okay, anti-clockwise direction. That means RHS side should be elevated. Understood? Now just create in your mind about a rod. There is a curve and it is turning into here. Can you see? It is turning this way, so this side should be super elevated. Okay, because when a vehicle is traveling like this, the centrifugal force is to this side, so you have to elevate RHS side to avoid vehicle being toppled or skidded. Okay, no, it doesn't topple, it is being skidded away. So RHS will keep it as 2 point. Now you have to check again that table as well. Okay. So you are considering 40 kmph. If it is 85, it should be 2.5, right? Super elevation. Okay. Then we'll take RHS as now RHS as 2.5 and LHS as minus 2.5. So here left outside shoulder, everything you have to give left side minus. I can copy it. Copy left outside lane, then left inside. If you want you can give, but it doesn't matter. Okay, it is not necessary. And right, it should be plus 2.5. Okay, here left is side lane minus 2.5. Right, everything should be right, everything should be plus 2.5. Now this is how it's coming. And here when you are going to end the super elevation, okay, it is 103. So since it is 103.6, we will take it as 104. So 12 should be inside, 24 should be outside. Why 1/3, right? So if it is 12, it is 92. 92. So we'll add here, add station 92. Here there comes transition out region, manual station, assign critical station, that is end full super. It is going to end the full super elevation. Okay, so you have to go there and come back. Here end full super, That is the same superelevation. All left are minus, and all right are plus. Okay, now can you see that it is being shown here? L is minus 2.5, R is 2.5. This Fs means full super elevation. Full super elevation ends here. So it has to come down like this. So 92 plus 3, 36, because super elevation development length is 36. How much is that? 92 plus 36, 98, 108, 118, 128. 128. Add station 128. Right click, assign critical station. What is that one? Begin normal crown, because it goes back to minus 2.5. Begin normal crown. So that means everything is minus 2.5. See what happened? Now it came back. Okay. Did you understand? If you didn't understand, we'll consider this curve as well. Okay. Then you will understand. Okay. Here it is 450. So what is our design speed? It should be 50. Okay. It is greater than 105. So it should be 2.5 super elevation. Then here super elevation development length you have to calculate. Just think that you calculate and it came as 36, right? 36. So you have to have 1/3 inside the curve, 2/3 outside the curve. Okay, so what? This is 244. So 1/3 of 36 is 12. That is 256. And here 244 minus 24, that is 220. Okay, 220, that is where this normal super elevation ends. Okay, so now you can calculate. Insert, right? Edit super elevation, tabular editor. So this is a curve number 2. Curve 2, right click, add station. 244 minus 24, that is 220. Okay, 220, that is assign critical station n normal crown. Okay, n normal crown. So now can you see it is minus 2.28, it is coming like this. Why is that? When you go to, because it is trying to, at the end it is trying to go into 0. So one thing we can do, this is a trick, right? So before doing these things, you go to the final curve. Final curve is curve 13. You go to add station and select this 1179.68. Don't go to 686. Then it is not going to work, right? And you put everything. You just give it as a assign critical station, say n normal round or something, and give here 0, right? You give minus 2.5 everywhere. You have to come back. Final one, right? Say minus 2.5. Then most of these things will be automatically corrected. Here, now it is there. Now we'll go to 220. We'll remove this one and we'll add it
Uh,
again. Somebody's mic is switched on. Please switch off that. Add station. So you go to 220, right? And then you go to manual station, assign critical station, n normal round. Here can you see that minus 2.5 automatically came? Why? Because it is 2.5 here, minus 2.5. At the end also minus 2.5. So this automatically comes as minus 2.5. So this saves time. Okay. Here. Now 220 plus 36, that 256. That is where the begin full super starts. Full super starts here, anti-clockwise direction. That means RHS should be elevated. So we'll go to 256. 256. That is begin full super. So RHS should be plus 2.5. Here 2.5. You have to come back. Otherwise it is not taking. It is a bug here, right? All right should be 2.5 plus. Now save the drawing time to time, right? Now you have to check whether there is enough space for you to go down and come back. Now see here, right? So I'll take the calculator. I can't do all manually. Okay, now check here. Here starting station is 359.537 minus here end station is 328 plus 468. Then it is 31. Okay, so here for this one to go down and come back, you want minimum how much? You want 48 minimum. Why? 24 outside, 24 outside. So in that case, you have to consider this as a the closely space, closely space, what? Closely space reverse curve. So there what you do is, you are going to consider the middle of this. I'm very simply I'm telling, right? Otherwise there are so many big calculations. Since this is 2 minus 2.5 super elevation, since this is minus 2.5 super elevation, you don't have to go into that much of calculation. You can just take the middle of it. So if it is 31, if you divide this by 2, that is 15.53. So you add it to the end station plus 328 plus 468, that is 344. So there is some, I'll just draw a line here. So your super elevation development has to come like this, and that length has to be 24. That means you have to minus 12, that is 660. Sorry, where again the 660, 359.537 minus 328.5468, okay, divided by 2, 15.5345 plus this one 328 plus 468, that is 344. So you have to deduct. Now you know this should be 36, right? So you have to deduct 18 here, that is 326. So you are going to end it here, 326. At station 326. 326 is n full super. N full super. So here also everything should be, right, everything should be plus 2.5. Okay, then you have to add plus 36 here, that is 362. 362 to the other curve. Curve 3 at station 362. That is the begin full super of this curve. Here you can see it is turned into the clockwise direction, so LHS should be elevated. So that means it has to go like this. Okay. So you go to begin full super. So here it interchanges plus 2.5. LHS side, everything LHS should be plus 25, plus 2.5. And RHS side should be minus 2.5. Right. Now how's that? Now the thing is, this acts as a closely spaced reverse curve. Now can you see that super elevation changes its direction when it reaches these two curves? Okay. Now the same way you have to insert the super elevation. Okay, in the same way you have to insert super elevation to complete this one. Okay, so here this is a normal curve, so you can end the super elevation somewhere here and then get it down. So somewhere here it will start again like that. Okay, so this manual method is too much tedious. Okay, therefore, I have developed a small program in the sense macro enabled Excel sheet. Now, next day, I'll teach you how to do the supervaluation calculation using that Excel sheet. But you know, even when our professional review engineers are coming to the highway design office at Road Development Authority, I do not give away this supervaluation development Excel sheet at once. Why? Because then they don't know how to calculate the supervaluation and how to insert this one. Okay, you can use whatever the program, that is okay, but you have to know the theory. Otherwise, you are going to be dumb. You are going whatever that is being given by the uh, program. That's not going to work. Now, do you know that AI is getting most of your jobs? So, do you think that you will be jobless because of AI? No. Right now, you know, nobody will be jobless since AI. Now, you know, those days, if we speak about transport, earlier we didn't have cars or trains, we had the bullock carts. Now, once the car and the trains came, train means locomotive trains came, what happened was these bullock cart riders lost their job. But nobody went starving because they found some other jobs. And some other group of the society, they became drivers and locomotive engineers. So AI is not going to replace the engineers. So what happens is you should be able to exploit AI so as to get your work done. This is something like this. It's not AI. Okay, this is not the AI. This is computer program. So what you are going to do is it can, have you heard about this thing that for the computers it is garbage in garbage out? If you give wrong details, you are going to get a wrong result or wrong output. So you have to know the theory and then you have to insert so you have to input the correct things. Okay, so the next week we'll try to finish the vertical profile, and I'll be trying to do some cross section as well if we have time. Okay, but once we have finished the vertical profile, that will be enough for your assignment, right?